are going to talk about gravity today. It's an extremely windy day, so bear with that. My hair is going to be flying every way. But so you guys are probably in high school or in an introductory physics class in college, or maybe even in middle school, which is awesome. And you probably know a little bit about how physics works, things like units and symbols. So for gravity, the main symbol is going to be G, which G is specific for acceleration. So G is an acceleration. It's the acceleration due to gravity.
Alright.
This is a constant value on Earth, and we're going to only be specifically talking about gravity on Earth today. In another video, we'll talk about gravity on any planet and how we come up with this value for gravity on Earth. So this is 9.8 meters per second squared on Earth. If you're using other values, you would change this value to fit the units that you would be using. So other important symbols are force. So gravity is a force. So we, in most common physics practices, use F for force. So that's easy to remember. And force is in units of newtons. So I like to put brackets, and I put N for newtons. So the way we're going to get force out of gravity is by Newton's second law. Newton's second law is one of the most famous laws in physics. And you've probably heard stories about Newton developing his theories on gravity, but now they're laws. So Newton's second law basically tells us that F equals ma. If you've heard it many times before in your classes. So in the case specific for gravity, gravity is the acceleration. So force equals mass times g. G being the acceleration due to gravity on the Earth. So I like to write specifically F sub g equals mg. And your mass here is in units of kilograms. So that everything works out in your unit analysis. So this is going to be in units of kilograms times meters per second squared. And that right there is the unit analysis definition of what a newton is. So that's something that can really help you along your way in physics is how to do unit analysis. So this is equal to newtons. So we will do an example of, I'll just do an example of this analysis. This is very basic math, multiplication. Most of the time in physics classes, you'll be able to use a calculator for this, because multiplying by 9.8 meters per second squared is not really simple. However, you can use 10 if your teacher does not let you use a calculator, because 10 is very close in high school level physics. So that's a good approximation to get these values if you do not have a calculator handy. Alright, hey guys, so our example today is going to all the directions. So X, Y, and Z, and any angle off of them. So we're going to make it simple, and we're just going to look at Y. Because we're going to look at the forces that are acting up and down on someone, because that's the direction gravity is applied. Gravity is applied towards the center of the Earth. So no matter where you're standing on the Earth, as long as you're standing on a flat plane, gravity is pointing down. So just looking at a person, we're picking a person to weigh 70 kilograms. What forces are acting on this person? They're going to have a force of gravity acting down. And we're going to label that as an arrow because force is a vector. So force of gravity is acting down. Whenever you have a force of gravity acting down, you have an equal and opposite force. That's going to cancel it out. And we're going to discuss why it cancels it out in just a second. So this is called the normal force. This is the force that's acting up in order to keep your body from squishing itself at a rate of 9.8 meters per second squared. So, why do they cancel out? Because I don't have an acceleration in my y direction. I'm standing still. I'm not accelerating up, I'm not accelerating down. Force of gravity to be negative because it's pointing down, we want to say negative direction. That's what makes them a vector. So don't forget, it doesn't matter if you called force of gravity to be positive. All you need to do is to make the normal force negative. But I like to make down be negative and up be positive. So I'm going to say that that is equal, I'm sorry, not equal to yet. I'm going to say we're going to add the normal force to the force of gravity, because those are all the forces that are acting on me when I'm not moving. And those are going to be equal to the mass times the acceleration. Well, what's the acceleration? Nothing's moving, so the acceleration is 0. Now, don't confuse that. You can have 0 acceleration when you are moving, but in this case, there's no motion, there's no acceleration, everything is still. At an acceleration of 0, a velocity of 0, no displacement at all. So now we have these two forces summed, which is why it's the sum of the forces equals ma, equal to 0, which means that they're equal. So we're going to bring Fg to the side that is 0. So Fg is equal to Fm. And that is how you would solve your normal force. But in general, just to find your force of gravity, all you need to do is say that the force of gravity is equal to ma. It never changes. So, Fg equals ma. But we're not accelerating, other than the force of gravity, which always has an acceleration. It has an acceleration due to gravity. So, Fg equals the mass of the person, which is 70, times an acceleration of 9.8 meters per second squared. And this, again, is in kilograms. And to make this easy, because I don't have a calculator, we're just going to say 9.8 is 10. So here we have a force of gravity of 700 newtons. Now, that is also what the normal force is equal to, because we solved that Fg equals to Fm. And that is really simple and a really important topic for you to understand. The theory behind it is really easy, really important. So just, if you have any questions about it, leave it in the comments below, and we'll address it in either any post or a future video. Thank you.
Tonight, I'm gonna have myself a real good time.